move on to this next module where we talk about the real meat and potatoes of data networking, which is encapsulation. So far up to this point, I've been giving you a lot of definitions for a lot of words. I've been trying to compare it to something in real life, like having a conversation with our friend, or Homer meeting Marge and calling her up, and using that to build some models so that we can understand better how data communication works in networking. So what I'm going to do here is start off by re-examining that OSI model that we've looked at in the previous two modules here. I want to introduce the concept of data encapsulation. I've kind of teased this in the last video when we looked at how messages get addressed and moved across a network. In this module, we're going to take that to the next step. I want to identify the names of data chunks. These are very important. They're very precise names. They have very precise meanings. And when we use these precise names to identify the components that we're looking at in data networking, we're much better off being able to communicate with others, as well as have a really solid understanding of how data is organized when we're sending it across a network. So let's jump right in and look at the OSI model here. Now, we built this OSI model coming from the physical layer going down to the application layer. Remember, the physical layer is where we have our medium, like wires, radio waves, or glass and fiber optics. And the application layer is where we have our data that we're trying to send. So that's where our websites exist and the protocols that we use to transfer those. As we look at the OSI model, I noted in the previous module that layers 5 and 6 are not necessarily relevant when we're trying to understand how data networks move traffic. Although there are protocols that operate there, I really like to wrap all those protocols up and talk about them as application layer protocols, because that's what's important here when we're talking about data networking. I always like to talk about the OSI model starting with the application layer and working our way down to the physical layer. The reason for this is it's often easy to conceptualize the application layer stuff. It's easy to conceptualize a website because if you're watching this video, you most likely went to a website to access the video. It's possible you went through a mobile app, but effectively, most of us that are watching this video have browsed to a website on the internet before, which means we have the concept of what the website is for us. I can use that as a starting point then to talk about what's happening in the rest of the layers of the OSI model. Start with application layer, layer 7. We have our user here. A user wants to go to pluralsight.com to watch some videos on data networking. So she types in www.pluralsight.com into her browser, and up pops the web page. Well, how did that happen? We're going to go through a pretty sophisticated process in order to move this website document from the Pluralsight servers at pluralsight.com to our PC on our desktop. So what happens is this. We take that website, and the website is a big chunk of data. And oftentimes that website is so big that we have to send it in more than one chunk. So what we do is we're going to break that website up into multiple chunks. And what we're going to do with it is take a chunk of data and add a header for the transport layer. So we're going to take one of those chunks of data and we're going to put it in the payload of this package. And this package that we have here has a header on it. And that header has a source port, a destination port, some flags. The flags are just identifiers of a certain type. We have a sequence number and an acknowledgement number. These are just the information that we need at the transport layer. Now, we haven't identified source port, destination port, all this stuff yet, and we have to start someplace. So here I am. I'm introducing it to you. We don't know what all those things are yet. Some of you probably know enough to be dangerous and know what those things are, but for the time being, all we're going to do is accept that this transport layer is effectively an envelope. And we're going to take a chunk of data from the application layer, shove it inside of this envelope, and then address the envelope. We call this envelope with a chunk of data in it a segment. All right, so any chunk of data with a transport layer header, we call a segment. In this case, I have shown a TCP segment header. There are other protocols at the transport layer We will definitely get into all of those. For the moment, all you have to know is that at the transport layer, when we're using TCP, TCP adds information to that header so that it can properly operate. And attached to that header is data. We call this the segment. Now that we have our transport layer segment built, we can now move down the OSI model and go to the network layer. Now at the network layer, what we're going to do is we're going to create a network layer header and have a payload section, and we're going to take our segment and we're going to put it into the payload section, much in the same way that we took the chunk of the website and we put it into the payload area of our segment. So now we have a network layer chunk of data, which we call a packet, which is nothing more than a chunk of data with a network layer header attached. In this case, we have an IP header. IP is Internet Protocol. It is a network layer function or an internet layer function if we're talking about the TCP IP model. And this packet is addressed with a source IP address, the global IP address for networking, a destination IP address, a value called the TTL or the time to live. This value is used so that if a packet goes through too many routers on its way to its destination, the routers will say, this packet appears to be lost, and throw it away. So that TTL value, we're going to explore that in detail because there's several protocols and utilities that will make use of that TTL value. So we'll take a deep look at TTL later on. The other piece here is the other field of our packet header, and that's simply protocol information that makes IP work. It's not really critical to understanding how data networks work. Next, we're going to go down to the data link layer. So at the data link layer, we're kind of going to lather, rinse, repeat this. So now we have our original chunk of data, the website, that we stuck in the payload of our segment. We took our segment and put it in the payload of our packet. And now guess what? We're going to lather, rinse, repeat, and take our packet and put it into our data link layer header. Our data link layer header plus our packet is now called a frame. A frame is nothing more than a chunk of data with a data link layer header. In this case, our data link layer protocol is Ethernet. In Ethernet, we have a destination MAC address, a source MAC address, and a layer 3 protocol listed in our header information. That layer 3 protocol information is nothing more than identifying what kind of packet is attached to the frame. The MAC addresses are, of course, an Ethernet function, and this frame allows for local communication on a network. And if you look very closely, in the end there, you will see our chunk of website that we're trying to send across our network. Now I have all that segment and packet header information all compressed there. It doesn't necessarily mean it's compressed in the real world. I just wanted to be able to put all of this on one single slide, so I compressed it down. So it's not technically being compressed as in data compression. This is just a visual compression on the screen so it all fits there. But ultimately our frame does contain that chunk of website that we're trying to send from the web server over to our workstation. It just has all this header information attached to it as well now so that we can transport it over the network. Now, this reminds me of a nursery rhyme at this point, you know, of this old lady who swallowed a fly and then she didn't know what to do, so she swallowed a spider to catch the fly. And then she swallowed a bird to catch the spider, and she didn't know what to do with the bird now, so she swallowed a cat to catch the spider. And she keeps swallowing these larger and larger animals to catch the next one, right? And it gets to be a bit absurd. And in data networking, it can feel like that as well, because we are actually taking information and encapsulating it, and encapsulating it again, and encapsulating it again, and encapsulating it again. And when we get into high-level advanced data networking, we're going to find out that we do all kinds of crazy stuff with our packets and our frames as far as encapsulation goes. So encapsulation is a cornerstone of data networking. For this, what we need to know is that exactly what's happening at each layer of our OSI model here, so that we can identify the segment as a layer 4 function, transport layer, the packet as a layer 3 function, network layer, and the frame as a layer 2 function or data link layer. Now all of this, once we have all of this done, we're going to actually send that frame down to the physical layer. It's going to convert it to ones and zeros and then convert it to an electrical signal to go over a wire or over wireless or maybe even lasers. Let's wrap up what we've done in this module. We examined the OSI model and we identified components within the OSI model that represent data plus a header. We saw that with a segment is a transport layer header plus a chunk of data. Usually that data is from the application layer. We identified a packet. Packet is a network layer header plus some data. That data is usually a segment. Now we also call the network layer the internet layer in the TCP/IP model. So our packet exists at either the network layer in the OSI model or the internet layer in the TCP/IP model. And then we have our frame. The frame is a data link layer header plus some data. The data is usually a packet from the network layer, but it doesn't have to be. It's not always a packet. But a frame is a data link layer header. We can also call this the network interface layer in the TCP/IP model. So frames exist at the data link layer in the OSI model and the network interface layer in the TCP/IP model. At this point, if you can memorize these three pieces of terminology, it's going to take you a long way in future networking videos, as well as understanding how data networks work. Understanding how data networks work revolve directly upon understanding the vocabulary we use to describe it. If we can't use the correct vocabulary to describe it, we're going to have a really hard time understanding what's happening because it's going to introduce a level of complexity that we may not be interested in learning data networking. Data networking is super simple if we can break it down into tiny components. And if you haven't noticed yet, everything we've done so far is to continuously break down and identify language to describe these little intricate parts of data networking. I hope you enjoyed this. Let's move on to the next video, which gets us into addressing and our first demonstration of this video series.